Section 10.3, Determinants and Cramer's Rule. Determinants is a numeric value for a matrix. It has to be a square matrix. And the determinant value has special meaning, and we're going to talk about that in this lesson. For these set of videos, we're going to focus on a 2x2 matrix. If you want to, I'd be more than happy to add on some additional videos that looks at matrices that are larger than 2x2. We can look at 3x3, 4x4, 5x5. But for the purposes of this class, we're going to keep our focus on a 2x2. We use our determinants when we're solving linear equations with Cramer's rule, and that's something we'll talk about later in these videos. The way we find a determinant is if we have matrix A, which equals A11, A12, A21, and A22. Then the determinant, which we use this notation, which looks like absolute values, the determinant of A we get by taking A11 multiplied by A22 minus A21 multiplied by A12. Another way that you see this written in textbooks is that maybe the matrix A is defined by A, B, C, D. Then the determinant of that matrix A is AD minus BC. Normally textbooks will focus on this definition down here, the AD minus BC, and that's what you'll see most commonly. But let's look at some examples. I want you to find the determinant for the following matrices. Try it on your own first, and then resume the video when you're ready to check your answer. All right, for this first one, the determinant of A, you want to take negative 2 times 3, which is negative 6, minus negative 1 times 3, which is a positive 3, or I'm sorry, negative 3. Then the negative makes this a positive, so we get negative 6 plus 3, which equals a negative 3. Determinant of A equals negative 3. Now let's look at B. We want to say the determinant of B equals 2 times 6, which is 12, minus negative 4 times negative 3, which is a positive 12, and this equals 0. The determinant of B is 0. Having a determinant equals 0 is actually very important. What that essentially tells us is that one row is a multiple of the previous row. If we were to write this out, this would mean that we have 2x minus 3y and negative 4x plus 6y. These are the same equation, just scaled by negative 2, which means something very important later on when we look at actually using determinants to solve for a system of equations. But for right now, just being able to find these numeric values is good enough. Again, we can evaluate determinants for matrices larger than 2x2. We won't be looking at this in my class, but if you're intensely interested, and that should be interested, not interesting, I'm sure that all of you are intensely interesting. I can post videos, just email me or leave a comment on the page asking for them.